So now I'd like to start our introduction to MATLAB programming. So as you all know, this will be a large part of the course. And so I wanted to begin by providing an overview of MATLAB, why it was developed, and how we use it in the study of human movement. Okay. So, for those that don't know, MATLAB actually stands for Matrix Laboratory. And as such, it's really a program that's designed to perform what we refer to as matrix operations efficiently. And so, in industry and abroad and in other domains, MATLAB is primarily used for, of course, manipulating matrices, data visualization, creating algorithms. So when we talk about programming, oftentimes what we're really referring to are algorithms. And you can think about these as sequences of steps that you might perform to solve a problem. So just to get ahead of this, one of the things that people find most challenging about programming is that you have to be very explicit in the steps that you tell the computer to execute. So what you'll find is that many times if your code doesn't work, either there are steps that are missing in your algorithm, or oftentimes the what we call syntax might be incorrect. And we'll refer to or provide more examples of what that means a little bit later. You can also use MATLAB to create user interfaces. And so what these are ways that you can interact with your computer without having to necessarily write code. So you can think about most any program that you use, whether it's Excel, Word, or anything else, has a user interface, often a set of buttons that you can press that perform certain actions. So you can create these types of user interfaces using MATLAB, and often those can be really handy for running experiments or even processing certain types of data. MATLAB also has a capability of interfacing with other programming languages. So if you're completely new to programming, just be aware that MATLAB is, of course, not the only language in which you can program. But we think it's a really great language to start with for scientists because it has really great. I think it's very user friendly. It has really great help resources and tutorials, which we will review shortly. Okay, so how do we use MATLAB in the study of human movement? We're primarily going to use MATLAB as a way to process and analyze our data. When we think about programming, one of the key advantages of writing a program is that it allows us to simplify analyses that might otherwise be cumbersome. You can imagine if you have data taken from, let's say, 10 trials of some movement, and this is motion capture data, and you record that data for 100 participants, it would be extremely tedious to try and process that data using something like Excel, where you need to copy and paste multiple columns and so on. So programming is really a way that we can make these processing steps more repeatable and robust, and even process our data much more quickly. So one of the things that we will start with is to really help you all gain and I guess an understanding of the relationships between spreadsheets, which is maybe one way that you might be accustomed to looking at data, and then matrices or tables, which is how we will most often represent data when we're dealing with it in MATLAB. So we also use excuse me, MATLAB for signal processing, for instance, filtering data, removing outliers, and doing other types of transformations to view our data in a different way. You can also use MATLAB for statistics. So we would call these inferential statistics. So where you're actually testing hypotheses. This is something that many people don't realize when they initially start using MATLAB. You may have been exposed to other software packages, SPSS, for example, to perform statistics. But one of the things that I really like to do when possible is do all of our analysis from basic data visualization, processing, and statistics all within MATLAB. Of course, Data visualization is something that we will do quite a bit throughout the course. You can also develop models and simulations in Matlab. This is, I think, a really powerful tool to really force you to think through how deeply you understand a process that you might be studying. So this is something that you would do in more advanced courses in the division. We won't really be touching on this in much detail here. So as one example of the type of model that you might develop, you could simulate muscles in different ways, attach those muscles to a simulated limb, and perform essentially biomechanical analysis within MATLAB. All right, so one of the things that I like to really start with and help provide an overview of the data analysis process is what we refer to as a data analysis pipeline. So one of the things that you will note throughout the course is that I like to take resources that I find via Twitter and integrate those throughout our course. So let me go switch to this link. Okay, so this was a post that I found, I believe, early 2021 from, I believe, a statistician who was just sort of diagramming their data analysis pipeline. So if I scroll down here we can walk through these steps, and these steps are things that we or you would also want to consider as you are analyzing your data. So the first is thinking about what is the question that you're trying to answer. This may seem obvious at the start, but I've seen many different times that people will sort of provide figures or some quantitative analysis to me without actually specifying why the data were analyzed that way or why the figure was created in that way. So you always want to think about the question that you're trying to answer when you are creating an analysis pipeline. So in some cases, if you have once you have your question, you may not actually need to collect data. Right? So there are, of course, sort of thousands and thousands of data sets that already exist. And there are a lot of resources now that make these data sets available for other researchers. So this is something that I think has been really exciting in the field over the last several years. I'll highlight one of these resources later in the course. But I think this is a really important point here, which is that while you may find data sets that appear to be useful to answer your question, there are various reasons why they may not be appropriate. And this often has to do with issues associated with the experimental design, so how they determine the trials that the participants would perform, as well as with issues with data collection, setup, reliability, and so on. So whether you find a set of data that already exists or design and execute a study to collect your data, you end up with a data set. And one of the things that I like about this pipeline that's sketched out here is this idea that you're often in data analysis going back to reassess or revise different parts of this pipeline. Okay? So it's not that you collect your data, you write all your code, and you're done. As you start to dig into your data more deeply, you will often, almost, I would even maybe say always, find things that you need to do in order to make that analysis more rigorous. So some initial steps that you might need to do, depending on how you collect your data, you may want to organize it in different ways, or for instance, if you record data on, let's say, Qualisys, which has their own proprietary data format, you might need to export that to a format that can be imported in MATLAB. Maybe you want to combine data sets. So this is the idea of merging data sets. For example, if you want to analyze a set of data from a group of participants, but you've recorded, each participant's data separately, you might write code to combine all that data together. From there, one of the very first things that you should always do when thinking about data analysis is to visualize your data. We will come back to this time and time again throughout the course. We often, I'll say, in interacting with students, and even when I was a student, one of the things that you're often sort of in a hurry to do is to get a result, and oftentimes that result is in the form of some statistical analysis or a hypothesis test, right? You're you really want to see if there's an effect, so you sort of crunch through your data and provide your advisor with some p-value that analyzes the difference in means between two groups, right? So one of the things that I think is really critical when we talk about data analysis is slowing down to make sure that every step along the way is done rigorously. So several things that you might do when exploring your data. You might, visualize each data point, count them to make sure you have the correct number of data points. Look for values that are missing. We'll talk about data distributions later on. So, in other words, you might think about the range of your data, right? If you're looking at height of your participants and you have values between, I don't know, let's say 60 and 80, and then one of the values is 1.4, right? You know that is probably a case where you recorded data in different units, right? Inches versus meters. Um, you also want to think, and this is really most important to do early on, is if I have variability in my data, right? People perform the task differently across trials, or I have differences between participants. You really want to think about what are all the possible reasons why I might see these differences. Okay. So we'll discuss this in far more detail later on, but this largely deals with the issue of confounding variables. So once you've visualized your data, you've processed it, there are some steps missing here that we might do with respect to signal processing and filtering. Then you will then move on to some sort of statistical modeling. And while this is not a course on statistics, I really like having this highlighted here because you may not often think about statistics in the form of t-tests, ANOVAs, regression, really as being a form of modeling. But indeed, whenever you select a statistical test, you have made some assumptions about your data, and those assumptions can be really described as a form of model. So often you can do these, I think, couple of steps in different order. You might, um, you know, create figures that really show your data and show relationships among different variables, and maybe then perform your statistical analysis, or vice versa. And then ultimately, you want to communicate your results. This could be done in many different ways, right? Oral presentations and lab meeting, one-on-one meetings with your advisor, written papers, conference presentations. And then here's where you get feedback. And depending on, the time when you receive that feedback, you might go back and reassess different aspects of this data analysis pipeline. Okay. All right. So let's get back here. So one of the readings for the course, which is no longer required, is this textbook, Matlab for Behavioral Scientists. I just wanted to provide an overview of the chapters included in this textbook in case you have purchased it or are interested in using it. So I'll just click through these quickly. But this textbook, I think, is really great because it highlights a lot of the key tools or features in MATLAB that you might want to use as you are analyzing behavioral data. So this book, the authors here, believe all come from the psychology department at Penn State. And one of the helpful things about this textbook is that the examples are about different forms of human behavior. So it's quite close to what you might need or want. The examples are quite close to things that we might do in studying human movement. So there are several principles that I've pulled from that textbook that I think are helpful to highlight as you begin your journey into programming. So the first is to decide if a program is needed and then whether you should be the one to write that program. The second is being as clear as possible about what your program should do. The third, which is one of the most important, is to work incrementally. Okay, so we'll talk about all of these things in more detail. One of the things that I think most people have trouble with, and I would sort of star this if I were you, is to realize that in order to learn how to program, you're going to be making mistakes like every day, many times a day, and you're going to receive negative feedback from your computer in terms of beeping sounds or red text that is explaining to you why your code doesn't work. And so you need to be able to take this feedback, um, not treat it as a personal attack, and then use it to really learn how to improve your code in the future. Early on, it's helpful to program with a friend. I always give the example of, most of the sort of skills that I learned in programming, I learned as a graduate student while working in my office, trying to analyze my code, running into a problem, and then talking to my lab mate next to me. And we would often share different solutions to the various problems that we found as we were going through the process of analyzing our data. So if you do this for 4 years or 5 years as a PhD student, you become quite proficient at programming. When one of the key things with respect to making sure your programs are accurate is making them concise. So one of the things that we will talk about later in the course is it's often common that you need to, perform similar, let's say, bits of analysis throughout your data analysis pipeline. And it may feel intuitive to copy and paste code, but we'll talk about ways around doing that, largely because copying and pasting is liable to create more errors in your code. Of course, you want your programs to be clear and correct. So these are the 3 C's, which we'll review. Okay, so one of the first principles is to think about whether you need a program and whether that's a program that you should write. So we can take this example where you have a list of 9 numbers, and I ask you to find the largest number in this list, right? So let's say that we have a different set of numbers, and they're just the height of our participants. When you have just 9 numbers, you can just visually scan and pick the largest number. So that's quite trivial, and you wouldn't need a program for that. But imagine now that you're trying to find the largest number in this list. Okay? So now the list is much larger, or maybe you have many lists like this. And in this case, you might not want to go and scan through manually to find the largest number because you may be wrong. There may be sort of human error in that process. So when thinking about whether you need a program, one of the things you may want to consider is the task that you're performing challenging to do precisely by hand or manually. Okay? So the key 2 things here are, is it challenging, and specifically challenging to do precisely. So precision is key when we're talking about data analysis. A second key point is, will you need to do this multiple times? Okay? So it could be that a task is challenging to perform precisely, but you only need to do it once. In that case, you may not need to write a program. But if you need to do it multiple times, then it's often advantageous to have a program that you can run to do these things automatically. And then finally, the question about whether you should write it. There are, sort of probably millions now of examples of existing bits of code that either other people have written or functions that already exist in MATLAB, for example, that can perform these types of tasks. Right? So if I have a list of numbers and I need to find the largest number, right, there's a function in MATLAB called max that will do just that. So, you know, in our research and when I meet with students, whenever we're trying to maybe, let's say, implement what we think is a novel method or maybe even a sort of complex analytical process, we'll often look within MATLAB or within the MATLAB online resources to see whether or not some solution or code already exists that we can use ourselves. So the next point is to be as clear as possible about what you should do, and this is really the process of developing algorithms. So we won't go through this in great detail now. We'll come back to this a little bit later. But this figure here is essentially an algorithm for finding the largest value in a set of numbers. Okay. So it looks little bit odd. So we will work through this slowly. So first, we have this initialization block here, where we're going to keep a counter, that's k, another variable called LOC, or you can think about this as location, right? Where are you in the list of numbers? And then we're going to initialize this variable max as the first value in my data set. Okay. So again, imagine if you have a list of numbers, a good place to start is to say, and you're looking for the max, you can start by saying, let's assume initially that the first value is the largest value. So then as we move through the algorithm, we're going to increment our counter. So if k, so we're going to make k equal to k plus 1, right? So if we started with k equals 1, we add 1 to it, now k is equal to 2. Here, n is a variable that specifies the total number of elements in our list. So if k is greater than n, that basically means that we're at the end of the list and you want to exit. But let's say in this case, it's not, right? We just said earlier that the first time through here, k is going to be equal to 2. So now we want to check, is the second data point, so this is data of k, right? Is the second data point greater than the first? And there are two options, either yes, it is, or no, it's not. If it is greater, now I'm going to store the location of that second value. So LOC would be 2. I'm now going to change the value of max to be the value in the second element of my list, and then go back to the start. Okay. So basically what this is going to do is iterate or move through every value in the list to check and see if it's greater than what you currently have as the maximum value. Okay. So this is a flow chart that you might want to use when developing your own algorithms. You may see online, if you ever decide to do a search about developing algorithms, or you might actually see this in papers that you read. Sometimes algorithms are written as pseudocode, and what that means is this is a definition of your algorithm and the steps that you need to perform, but this is not code that you could sort of copy and paste into a program to run. Okay, so next up is this idea of working incrementally. And this really is, a key element of programming and data processing that many people overlook. And essentially, the reason for that is that, again, we're sort of all in a hurry. We're all under pressure to produce results. So what you want to be thinking about as you start to write code is that as you write, small chunks of code, you save, you check it, make sure it works, and then move forward from there. Um, this may not be sort of obvious to you now, but I'm sure many of you have probably lost files that you've been working on for quite some time, whether it's papers or other assignments, because you didn't press save. This also will happen with code. Another thing that will happen is that you will have a working version of your code. You'll go back and make some changes, save it, and then it stops working, but you don't have the original version. So this is something that we'll talk about a little bit later, which is this idea of version control. So one way to do this is to, once you have a version that works, save it, create a new version, and then start modifying that new version. I mentioned the principle of being open to negative feedback. You will all, if you're new to programming, become really frustrated over the course of the rest of this course, because you will receive error messages. Right? These are very frustrating. Sometimes they're really hard to interpret, but these messages actually tell you exactly where the problem is in your code. And if you do a little bit of digging, you can actually fairly easily interpret what the error is. Okay. So you always want to check your code, and one key principle here is that just because you don't have error messages, that does not guarantee that your code is correct. So here are two examples. Here I have two variables, x and y, and I want to plot x versus y. Okay? So this is actual MATLAB code here. And from this code, I get a figure that looks like this. Okay? So you can run the code, you don't get any errors, but it produces a figure. Okay? However, there's a problem here. And that problem is that in the first block of code, let's see if I have this here. Here, I should have x here, and then y adjacent to it. But instead, I have x and x. And now you can see that in the second example, I now have x and y. So this is a case where making sure that the output, the figure, looks like you think it should based on your understanding of the data is really important as a way to check your code. Okay, the sort of last three elements here are together referred to as the three C's in the text. First is to be clear. So this is a case where there are many sort of many different ways that you could write different operations when you're programming. But you really want to steer clear of really long, complex lines of code because they're difficult to understand. Instead, you want to break these up over multiple lines. Third point, which something that I will sort of try to reinforce throughout the course, is whenever you have a variable, you want to give it a meaningful name. So on the last slide, just to sort of provide an example, we use variable names x and y. Those are absolutely horrible names for variables. Okay? So when we're studying human movement, almost all of our variables are going to have some physical meaning, right? Height, weight, um, position, and you sort of go on and on. So there's no reason why you can't use what we might call human readable names for your variables. Fourth point is that as you start to write code, you need to add comments to your code. And these are texts that you write in your programs that are not executed by MATLAB. So these comments are helpful not only in case you need to share your code with somebody else so that they know what you're trying to do, but they're also really helpful for you if you come back to your code later on so that you can understand what you were doing. So we've mentioned this idea of being concise. Now I talked about the problems that might occur when you copy and paste code. You might go back and change one version of that code, but not the rest, and end up with a problem in your code. And so we'll talk toward the end of this module about creating functions that really help, um, are single bits of code that you write that you can sort of call multiple times as needed. And finally, of course, your programs need to be correct. And aside from understanding or writing algorithms and making sure the sequence of commands is correct, you'll need to learn proper syntax, so that how you use parentheses and brackets and braces to refer to specific aspects of a data set. You'll need to make sure you're using correct function names when you're using, for instance, um, you know things that were created through MATLAB, and you'll want to be able to interpret the errors that you receive while programming. So when you get these errors, um, they're often just sort of really subtle mistakes. And so you have to be sort of very careful to identify where the problems lie in your code. So being patient is one of the most important qualities that you can have as a programmer. Okay. So when you're writing code is just a form of another form of communication. Of course, you're communicating with your computer. So if there are errors, right, your program is not really useful. But you may often have to explain your analysis to your advisor or lab mates. And if they are familiar with MATLAB, then they should be able to read and understand your code, right? So you want to keep others in mind. And most importantly, often is that if you write some analysis code, you might have to come back to it, a week, 1 month, even a year or more later. And you want to make sure that it's written in a way that you can understand. Okay. So many different ways to get help with programming. I would recommend starting with MATLAB's help, and we'll go over an example of that shortly. MATLAB, one of the reasons why I personally really like MATLAB is that their help files are probably the best of any program I've seen. They provide lots of examples for all their different functions, and example code. And this is, I think, one of the best ways to really teach yourself how to program. You have the textbook that I mentioned earlier. If you own that, that can be a useful reference. Some people prefer a textbook over sort of let's say online or digital resources. MATLAB also has a set of tutorials which we will be using throughout this course. These are through the MATLAB website, and they rely on a version of MATLAB, as we've mentioned before, that you interact with through your browser. So here's the link for that. We will have Q&A sessions. So, when you get stuck, don't feel that you have to sort of beat your head against the table for hours and hours. We are available to help, and we can oftentimes problems with code are, like I said, very subtle. And if you're unable to find them, definitely ask for help. People like to use Google and YouTube. I find I put this sort of last because it can often be difficult to sift through the range of solutions that you find through those methods. So with that ends our introduction to MATLAB.